Okay, in this section, we want to look at business application development, which is a very, very important aspect in domain 3 of CISA. This is an area of which every IT auditor is expected to be very, very much familiar with. Okay, so how do we get systems? How will you expect an organization to get their systems? Okay, it's either they are buying the systems or they are going to build themselves. So those are the only two options available for an organization: either you buy or you build. And it's very important that the auditor is aware of the processes that are involved in the process of developing or buying applications. So that is why we have the system development life cycle, from the beginning of acquiring the system to the point of retiring the system. The auditor needs to know what happens at this stage. All right, in CISA, we have three basic models: traditional waterfall model, which is very common. Then we have the V-shaped model. We have the modern iterative model, which is a far departure from the traditional waterfall model. The V-shaped model is more or less built on the traditional waterfall model. All right, but the iterative model is a complete departure. All right, because the waterfall model basically works in an environment where there is stability of requirements. So you don't expect a lot of changes in requirements. All right. So the SDLC methodology does not encourage frequent changes in requirements, but that is allowable, that is acceptable, that is normal. All right, in the iterative model, changes are welcome, and of course, that is a high risk for the auditor to take note of. All right, so the waterfall model basically is just like the normal waterfall, runs from the top down. So we have 6 stages, starting from project feasibility. From there, we move to requirement definition. From there, we move to design. From there, we move to development. From there, we move to final testing and implementation. And from there, we move to post-implementation. So we finish one stage, we move to the next stage. That is basically what the waterfall model is all about. All right. And improvement or adaptation of the waterfall model, which is kind of advocated for by software testers, right, is the verification and validation model. The emphasis here is that once you are in a stage test, right, so you don't wait until maybe the end of they are finished developing the software and then you are not trying to find where the problems are. No. As you are finishing the stage, test it. And that is what verification and validation model is all about. All right. So requirement analysis, we are already preparing for user acceptance testing. All right. System design, we are at system design or high level design stage. We are already preparing for system testing. We are performing architectural design. We are already preparing for integration testing. All right. We are at module design. All right. The design of each of the modules in the application. We are already planning for unit testing. All right. And of course, coding is there as the base of the V, which you can see. That's why they call it the V model, the verification and validation model. So you verify the stage, you validate, you test it. So emphasis here is on immediate testing, early testing, at each of the stages. Okay, that is the verification and validation model. The iterative model, like I said, is a cyclical process. Let's have the first shot. Then, if there's a problem, we can solve the problem later. If there's a need for improvement, we can improve later. That's iterative. So changes are welcome. You don't like what we gave you, all right, we'll change it. Okay. You don't like it 2 times in a day, we change it 2 times in a day. So the frequent changes could become problematic, right? Because there could be loss of audit tray, poor controls can result. Please take note, agile method, prototyping, all right? All of those are iterative models, and of course, the risk is that the frequent changes may lead to poor controls. Okay, so SDLC basically has 6 stages, all right, starting from phase one, feasibility study, right? Feasibility study answer the question, do we really have a problem, all right? Because it's possible, you know, we don't really need a software, or we don't need to buy a software. There may be another software within the house that may solve the problem, that we're trying to solve. So whereby just rearrange some things. Maybe you don't need you need to upgrade the software you are using now. So it's not every time you just rush to the market. And that is what visibility is. So this is project management basically. Do we actually need a software? Do we need to buy? Do we need to do? So the first question is, do we really need a software? If we have a problem that we need software we solve, that's the question that feasibility studies is trying to answer. And that person is very, very important. So management need to ensure that whoever is championing the software purchase or acquisition should have a business case. So give us a business case with the pros and the cons, with the qualitative benefits, with the quantitative benefits, and project it for us. Defend it. Why do we need this software? What problem will it solve for us? What are we going through that this software is going to address? Then if you can't defend your business case, then the project dies at this stage for the benefit of the organization, feasibility study. So do we need a software? If you have a business case, and yes, we can all agree that we need a software. The second question is, do we need to build or do we need to buy? Because we may have internal capacity to build. So why not build if we have internal capacity? If the internal capacity is not there, or it does not make financial sense to build in now, then we have to buy. So that also needs to be sorted out. Okay. So this is a very, very important stage in system acquisition. And the auditor needs to ask the question, where is the business case? Was the business case presented or not? Fine. So if we are through with phase one, which is the project feasibility, the next stage is the requirement definition. We have now agreed that we have a problem that software can solve. Now, what are the departments that need the software? So we need to know the departments that require this software. Then we need to gather their requirements. All right, legal requirements, contract requirements, business requirements, security requirements. All those requirements will be gathered from all the users. And it's very, very important that users participate here. User participation is very crucial at phase two, requirement definition. Because if you don't have maximum user participation, what you need to have is what is called scope creep. Scope creep. Now, what that means is that along the line, after you have passed requirement definition stage, maybe you are about to even release the software, then you now realize that the software requirements are not complete. So you have to go back to the drawing board. You don't want that to happen. So that is what is called scope creep. So to address scope creep, you need to do what is called a baselining or freeze points. So baselining means you need to be able to freeze the requirement at a point in time. Maybe you can fix a date and say, okay, 24 December, this is it. All requirements, documentation and validation ceases. All right. So beyond 24 December, you want to make a change on the requirement, you have to go to, a change management process, which you have to now more or less report yourself to management. So, we need a new requirement added or subtracted from the frozen requirements. Then you have to defend yourself because you can get a query for that. Where were you when you were gathering requirements for these projects? So that makes it official that people know that everybody that needs to submit the requirement must submit the requirement before December 23rd. And of course, there will be consequences if it was determined that you are taking us back without any justification. So that's scope creep. So in the exam, please take note, baselining of which points can be used to address scope creep. So ensure that you have enough maximum stakeholder participation and requirement definition stage. All right, so we'll move from requirement definition. We have now documented all the user requirements, security requirements, and the rest. Now, from there, we now move to phase 3. Now, phase 3 depends on whether you want to buy or you want to build. If you want to buy the software, so what the next stage is software selection and acquisition stage. Software selection and acquisition stage is very, very important. Now, if you are buying, you need to have a process to choose your vendor and to choose your software. Let's assume is a software for accounting department. Right? We know what we want. We've already gathered requirements. The software should be IFRS, National Financial Reporting Standard, IFRS compliance. Should be able to process up to $1 trillion or dollar. Should be able to generate, of course, generate a statement of financial position of balance sheet. Be able to process in dollars, in naira, in yen, in pound sterling. All right. So we have all those requirements already stated. Should be able to integrate with other applications in the organization. All right. So and so on and so forth. We have all the requirements documented. Now we will now use this requirement as a basis to develop what is called request for proposal, RFP. Now, so the request for proposal now is now documentation of the requirements and the expectation of the client as regard the vendor, right? What to expect the vendor to act on ground. References from the existing customers, right? Number of years that they existing, proof of the financial reliability, stability, and so on. Then the requirements, the software requirements, now demonstrate to us how does the software you are vending, how is it going to solve this problem? Okay, so it's an accounting software we need. So somebody that has Sage, the vendor that has Sage is going to respond to the RFP. Somebody that has QuickBook will respond to the RFP. Somebody that has maybe a locally developed the accounting software will respond and show how your software modules or features can actually meet the requirements of that client. Now, so once the responses to the RFP have been done, then the steering committee on the software acquisition can now look at the responses and then maybe select the best 3 or the best 4. They invite those 3 or 4 organizations to come and do a presentation, live presentation at their office or maybe remotely, show us practically demonstrate this software. And from that, we can now select our final vendor. So this is very important. Everybody to be there as an observer through all these processes to ensure that we have transparency. So that is selection and acquisition. If we are buying, but if we are building in-house, so from requirement phase 2, we are going to move to phase 3B, design. So we have the requirements. So you give the requirements documentation to the developers, and so from there they can actually decide how the software is going to be, right? The modules, the architecture, the integration. All right, so you can now use the data flow diagram, flow charts, algorithms, and the rest. So structure the programming diagrams can then be used to now show us how the application is going to be, the model basically. So they create the model of the application using the requirements. So of course, we have to be sure that what is designed is actually in line with the requirements submitted by the users. Okay, so we move from phase 3 to phase 4. So for phase 4A, if we are buying, so we move from 3A, software selection and acquisition, to configuration. So we've finally chosen the software, we bought the software. Let's assume we selected Sage, we bought Sage. Now we have to configure Sage. So the Sage is bought by a company in Nigeria, so which means you have to customize the currency to Naira, but they also do transaction in dollars and pound sterling, so you have to customize the Sage to be able to process that. Okay, you have the subsidiary accounts, you have to customize Sage to be able to process that. Also, there are regulations from the supervisory ministry, federal ministry, so they have to also customize the requirements of those operators, and so on. Security policies of the organization based on information security policy requirements, those two will be customized. So that's basically what configuration is all about. So configuration will be based on legal requirements, business requirements, compliance requirements, and the rest. So configuration is very key, and we have to ensure that we have a configuration repository so that we can always check to confirm that the configuration has not been changed without authorization. All right, so then if we are developing in-house, we move from design stage 3B to 4B development. So which is where we do the actual coding, depending. So we pick the programming language depending on the kind of application we want to develop. Of course, we have Java, Python, C++, and the rest of them. So depending on the kind of application you want to develop, you can pick the best programming language, pick your integrated development environment, ensure the test environment is separated from the lab environment, ensure there is proper software testing. So these are very, very important before we move the application to the live environment. Ensure that the team that move the application to the live environment is not the same team that developed the application. This is a serious control that we need to put in place. All right, we'll talk more about this later. Then we'll move from phase 4B development, all right, to phase 5, okay, which is the final testing and implementation. So the final testing, you have to carry out your quality assurance test. You have to carry out your user acceptance test. All right, then you go live. Okay, you have a choice when you go live. You can choose direct support over, which means you just move from the old system to the next system straight. All right, that is quite risky. But you can do parallel port over. You use the old system and the new system for like 2-3 weeks or more, a month, depending on management decision. Then that 3 weeks or so will be used for the users to acclimatize the new system, while IT is verifying that transactions at the back end of the two systems are synonymous before we retire the legacy system finally. Okay, so of course, during that implementation, a lot of things could go wrong and a lot of things do go wrong. So you need to have a help desk, people that are trained already by the vendor on ground. The vendor too will have their own help desk team on ground. So at least you need 2 layers of help desk so that your local help desk will not solve the problem. You can escalate the problem to the vendor or help desk. So from final testing and implementation, we move to post-implementation. So at the post-implementation stage, the project has now started, the software has stabilized. So basically what we are doing is post-project review. We want to confirm that the business case is justified. So at the project feasibility study stage, we'll be given a business case. A lot of benefits have we've been told that we are going to get certain benefits. At the post-implementation stage, we actually want to confirm whether we are getting those benefits or not, and whether there are some challenges that are yet to be resolved post-cut over. All right, maybe there are training needed, maybe there's a need for a middleware, and so on and so forth. So all these will be addressed at the post-implementation stage.